everyone, my name is Satyaprakash Singh. Welcome to ATP STEM. Whenever we see any problem which is based on maxima and minima, we think of differentiating and applying second derivative test. But there is one more powerful relation which help us to find maxima and minima of any function. That is arithmetic mean and geometric mean relation. Let's see the relation. The relation is arithmetic mean is greater than or equal to geometric mean. So if we have two positive number x and y, then x plus y by 2 is greater than or equal to root of xy. Equality hold when two numbers are equal. If we have three positive number x, y and z, then x plus y plus z by 3 is greater than or equal to cube root of xyz. Again, equality holds if these three numbers are equal. If we have n positive numbers x1, x2 till xn, then x1 plus x2 till xn divided by n is greater than or equal to nth root of product of these numbers. Let's look at some important question based on this relation. The first one is the list value of alpha for which 4 alpha x square plus 1 by x greater than or equal to 1 for all x greater than 0. The condition is x is positive. Then 4 alpha x square is positive, 1 by x is positive. If you look at the solution for this question, anywhere you will see they apply differentiation and second derivative test. But I am going to give you one more method that will give the answer within 2 steps. And the method is arithmetic mean and geometric mean relation. So we know that arithmetic mean is greater than or equal to geometric mean. Therefore, I am applying arithmetic mean on 4 alpha x square, 1 by 2x and 1 by 2x. What I did, I just split 1 by x into two parts, 1 by 2x and 1 by 2x. So 4 alpha x square plus 1 by 2x plus 1 by 2x divided by 3 is greater than or equal to cube root of product of this number. Since we have three terms, we are applying cube root. Now, product of this number will give you alpha. X square will get cancelled out, 4 will get cancelled out, we'll left with cube root of alpha. Then we have 4 alpha x square plus 1 by x greater than or equal to 3 times cube root of alpha. In the given question, we have 4 alpha x square plus 1 by x greater than or equal to 1. That implies 3 cube root alpha can be 1. Then cube root of alpha will become 1 by 3. Then alpha is what? 1 by 27. Then C is the correct answer. 1 by 27. We have just applied arithmetic mean and geometric mean relation, nothing more. And this question has been asked in Advanced 2016. So this is one most powerful relation which help us to find maxima and minima. Let's look at one more question. So the next question is the minimum value of fx a to the power ax plus a to the power 1 minus ax where ax belongs to real and a is positive. Then what is the minimum value of this function? This is Mains 2021 problem. Let's look at this solution using A.M and G.M relation. So let's look at the solution. Here we have fx equal to a to the power ax plus a to the power 1 minus ax. We are writing as a over a to the power ax. Now, since we know arithmetic mean is greater than or equal to geometric mean, let's apply that relation on these two terms. If you apply this relation, then a to the power ax plus a over a to the power ax divided by 2 greater than or equal to product of these two terms. And what is the product of these two terms? Nothing but root a. Then we can say a to the power ax plus a over a to the power ax is greater than or equal to 2 root a. If fx is more than 2 root a, then what is the minimum value? 2 root a. That's all. So this is another perspective to find maxima and minima of a function using A.M and G.M relation. For more such interesting video, please visit our channel and don't forget to like and subscribe. Thank you so much.